no hot water and how to test a plate heat exchanger. My name's Alan Hart, and in today's video is an amazing video. This is a training video for new gas engineers, new plumbers, anybody who's going to be working on gas appliances, as long as you're gas safe registered and competent to do so. This is a training video just to help you and show you how to test if you've got a blocked or a faulty plate heat exchanger. This video today is from an ideal engineer, and he's sending us loads and loads of really in-depth videos in. So the videos are quite long, but they do tell you and do explain to you from start to finish on how to test these things. So without further ado, let's go and have a look at this video.
Hello everyone. In today's video I'm hopefully going to discuss something and show you something which will be easier on both me and you, the viewer, because my last few videos were all on the use of a multimeter and the electronics on the boiler. It's incredibly difficult to film holding the phone in one hand and holding a multimeter in the other. Also, my last video was incredibly frustrating as my phone was playing up and I was close to throwing it at the wall. So today we're going to talk about hot water issues, mainly fluctuating hot water or poor hot water, warm or lukewarm hot water, and most of you will probably guess that the first place you would suspect of being the cause is one of these, the plate heat exchanger. However, there may be more other issues with components within the boiler which could mislead or masquerade themselves as being a plate heat exchanger issue, but in fact it is not. For instance, a slow or weak pump will struggle to circulate the heat through the boiler, causing either an overheat or modulating the boiler to low fire. A thermistor could be out of calibration, sending wrong temperature info to the PCB. A diverter valve or paddle could be passing heat down a central heating flow pipe, causing lukewarm water. Or, if you had a standard efficiency boiler, atmospheric burner and a modular gas valve, the burner pressure could be too high or too low, causing either overheat or poor hot water. And therefore, I'm going to show you with just two simple temperature tests using only my analyzer and some temperature clamps. I'm going to show you how you can categorically prove or whether or not indeed the plate heat exchanger is restricted or blocked. It can save you a lot of time and effort. Now, these checks will only take about 5 minutes maximum, and it will take me longer to show you these steps as I'm explaining, and I'm explaining how to do it as we go along. 5 minutes in comparison to say half an hour or 45 minutes is a big difference. When you've drained the boiler, removed the plate heat exchanger, or even replaced it, filled and vented the boiler, only to find you still have the same issue, I think it's well worth doing these tests. You may also have to charge the customer for time that you've spent and unnecessary parts replacement, so you know it's worth doing these tests for 5 minutes. Granted, I will say that the experience, you can probably diagnose the fault as being a restricted plate heat exchanger 9 out of 10 times with just the symptoms alone, but there will be the odd occasion you will be wrong. And I've watched a couple of YouTubers show you that when they're on the job that they've diagnosed the blocked plate and remedied the issue, but they've never shown you how they've tested to confirm that this was the case, and that's what I'm going to show you today. As I said, there are two tests. The first one, I would hazard a guess that most of you will probably already know how to do, but the second one, I would guess that not many people would know how to do. Also, these videos are aimed at new recruits into the industry, and therefore I think we should get on and show you how to do these checks. So the first test we're going to do is called a temp diff test, or delta T test. And how we're going to set this up, we're going to analyze a set on the temperature differential setting. We are going to put one of our temperature clamps on the cold water inlet, and the second temperature clamp, if you can see there, on the hot water outlet. Now you need to get the temperature clamp on the hot water as close to the exit of the boiler as possible, purely because as soon as the hot water is leaving the boiler, it's cooling down straight away, and if you put it down on the pipework down here, for instance, you could be a couple of degrees difference in temperature. So if we get the hot water temperature clamp close as possible to the exit of the boiler, and then it'll give us a better reading. And what we're trying to ascertain is, with a combi boiler, depending on your power output of your combi boiler, you'll have a specific domestic hot water flow rate, which you can draw from the tap and draw through the plate heat exchanger. So depending on your power output, the maximum, this is a maximum setting, so the maximum hot water flow rate on this boiler, as you can see there, is 16.9 litres per minute. And what that basically means is, if I pull 16.9 litres of water through this plate heat exchanger out of my hot water tap, my boiler can raise the temperature of the cold water inlet by 35 degrees. So I've got a cold water temperature there of 21.3. If I'm drawing 16.9 litres through it and raising it by 35 degrees, I could technically get about 56 degrees coming out of this hot water pipe there. That's maximum. For instance, if I run the hot water at a slower speed, drawing less, let's say 14 litres per minute, I would pick up more heat. So what I'm going to do now, I'm going to run my hot water tap, try and get it as close to the 16.9 as possible, and what we're looking for in our delta T there is 35 degrees temperature difference between the cold and the hot, and we need to maintain that 35 degrees. If it's fluctuating up or down, or not even able to achieve 35 degrees, let's say it gets to around about 25, 30, and it starts to cool down, it can't even get to 35 degrees, that would indicate we could have a poor or blocked plate heat exchanger. So I'll set up this test now. This is not the best example. My flow rate, I can only get about 10 litres of water through my tap at present, so I'm probably going to pick up a lot more than 35 degrees on my boiler temperature differentials. So as you can see there, it's around about 10 litres maximum. I'm running the tap at full speed. So let's go back and see what we get. So as you can see, the boiler's fired. It's running. It's registering 62 degrees at present, and on our analyzer we can see the cold water temperature is 8.8 degrees, the hot water outlet temperature is 55 degrees, and our delta T, our temperature differential, is 47 degrees. It's obviously more than 35 degrees temperature differential, because I cannot achieve 16 litres per minute. I'm only achieving 10, and that's why I'm picking up more heat. But what you can tell from this is that it's actually achieved the 35 and exceeded the 35 degrees, and it's maintaining the temperature. That's a critical point we have to make, because a block plate heat exchanger will probably not even get to 35 degrees, and if it did get to 35 degrees, it wouldn't stay there very long. It would overheat, the temperature would drop around, say, back to around 20, 25, and then try again and try to get back to 35. The fact that I am pulling a lot more heat through my plate heat exchanger and it is staying a steady temperature just shows me that my plate is working okay. Another thing to consider would be the temperature on the front of your boiler. If a block plate heat exchanger or a restricted plate heat exchanger was inside this boiler, that temperature on the front would be fluctuating up and down also. It would be, say, hitting 60, going back down to 30, trying to get back up to 50. It would be all over the place. That is maintaining temperature. That is maintaining temperature. So that's our first test. Because of this video, we're going to say that, you know, for the purposes of this video, we're going to say that we didn't achieve the 35 degrees. It couldn't get there, it couldn't make it, it was bouncing all over the place, got to 20, 25 degrees, and therefore we have to do my second test, which I will set up now. So here we are on our second test. Now what I'm going to do, I'm going to check the temperature coming out of the plate heat exchanger on the primary water side. So to set up this test again, we've left one temperature clamp on the hot water outlet pipe where it is, but we've removed the temperature clamp off the cold water side now, as you can see, and we've connected it to the return pipe between the pump and the main heat exchanger. There's a thermistor right next to there. I don't know if you can see. We've connected it right next to the return thermistor. The reason for that is because we use the return thermistor on this particular boiler as the hot water thermistor. If you imagine back to standard efficiency boilers, you would have had a dedicated hot water thermistor, usually on the the hot water outlet of the plate heat exchanger. But for modern boilers these days, I think a lot of them use this technique. And the reason for this is, if you imagine, let's say for instance 80 degrees coming out of the flow of the heat exchanger, the top of the heat exchanger, let's say around about 80 degrees coming out, flowing into the plate heat exchanger. If we're picking up 35 degrees across here and out of the hot water pipe, we're going to have to lose 35 degrees across here. Effectively, this is a heat exchanger, so it exchanges the heat. So we're going to lose 35 across here, pick up 35 across here. So therefore, what I'm going to ascertain is the temperature should be almost exactly the same coming back from the pump to the main heat exchanger as it is coming out of the hot water pipe there. We should have exactly the same temperature if this heat exchanger is working correctly, to the point of around about 1 degree. And you know, depending on the calibration of your analyzer, 2 degrees out at a push, I would say. But the temperature of T1 and T2 should be almost exactly the same, and there should be no difference in temperature. Like I said, 1 degree, maybe 2 at maximum, but if you're getting 3, 4, 5, 6 degrees is a blocked plate heat exchanger. So I'm going to run the hot water tap now. I'm going to see what we get. Right, test 2. We've got the tap running again, the boiler's fired. I put the cover back on the boiler just because without it you can't hear me very well, but be rest assured that wire coming out of the bottom of the boiler there is connected to the return pipe back between the pump and the main heat exchanger. And if you can see, right there, T1 and T2 are almost perfectly the same temperature, and that is the hot water outlet pipe and the return pipe going back from the pump to the boiler. So like I said, you're losing 35 or whatever temperature you're losing across the primary side, you should gain on the main side, and then temperatures should be perfectly or almost exactly the same. If you're getting 3, 4, 5, 6 degrees temperature difference, then you have a block plate heat exchanger. It is minus 0.9, it's not even 1 degree difference. So that is your second test. If your first test failed and this test failed, you've got a blocked or restricted plate heat exchanger. And that's going to save you, it's going to pretty much prove almost without a shadow of a doubt that your plate heat exchanger is blocked. So yeah, hope that helps. That is a perfect way, saving you time and effort of taking it out, physically looking inside it to see whether you can see magnetic iron oxide, microbial bacteria, non-magnetic particles, calcification, lime. There's plenty of things that can restrict the plate heat exchanger, but this is definitely the way to prove that it is restricted. So I hope this helps. So last but not least, this is the part where I normally advise you on the specific part for the boiler, the part number, etc, etc. But in this instance, there's a possibility that you could clean the plate heat exchanger. Once our tests have proved that it is indeed restricted, you could try cleaning it, or you could replace it. And like I said, I would normally show you the part number, but for the logic and the volt, we've got, it depends on the kilowatt output for one. So we've got a 24, 30 and 35 in the logic, we've got a 26, 32, 40 on the volt. Both have had brass and composite water sets, so, and they've had upgrades and two, so there are plenty of plate heat exchangers that that I could take off my van and go through, but it'd be too ridiculous. So I thought I'd show you a way of deciphering the exact part for a particular boiler of ours. It's quite handy to have. If you work in our boilers quite a lot, this would be quite handy to have. And what it is, if you do an internet search for ideal part finder, you will get this. You can get it on the phone or tablet or whatever you want. Type in ideal parts, and this was what it'll come up with, and it'll ask you for the boiler name or BCG number. And what you need to get the serial number. The first 6 numbers is the identification of the boiler. So in this case we've got 213982. That's the boiler identification number. The numbers after that are pretty much how many have been made. That's the date when it was built, and that's the prefix, the letters at the beginning, AFQ, the prefix, but we need the 213982. So if we type, this is going to be difficult to do, I'm just going to type it in, bear with me a sec. (213.982) search. Let's come up with an Ideal Logic 35 boiler. Click on that. Click on View Boiler Diagram, and if you can see, it's hard to see, but the plate heat exchanger is 121. It gives you an exploded view. You can zoom into it, but I'm just going to show you that it says 121. So then, what we do, we find 121. It's part number for every single part on the boiler. Oh, I've gone too far. Hang on. It's hard to do with one hand. We're on to number 3, not number 2. Right, number 2. if we go to 121 177 530, and if you look here, I have 177 530. That is the plate heat exchanger for a 35 kilowatt Logic Combi with that serial number. You may need the first 3 letters depending on the model of the boiler, but it's the first 6 numbers that are mostly important. And now you've got the part number from your parts finder. You can phone up your supplier and say I need 177 530, and they'll be able to help you with that. That's handy to have if you work on our boilers a lot. I actually use that myself. I've got my iPad and stuff, but it's quicker on my phone just to do that. So yeah, hopefully that should help you diagnosing, repairing and sorting out the customer's hot water for them. Thank you very much for watching. Bye bye.
Thank you very much for that. As for testing, I've also got some Testo thermostats, and I'm going to test these. So I'll do a video on these shortly, and that'll do the same job as the cane. So I've got 2 of these. And we'll be able to put them on pipe work, and we'll be able to use this phone, and I'll just do a demonstration. I don't actually know how they work yet because I've not used them. Just got them now. But yeah, we'll do a test. We'll do a video with these as well. So if you've got any questions on these, then again, please put some comments below, and I'll try and add them into the video that we do. I hope you found this video of some use. I found it very, very interesting. I like these type of videos. Please remember, if you're going to work on gas boilers, you must be gas safe registered or competent to do so. These videos are designed to give you more knowledge, and always read the installation instructions. Go on as many of the manufacturers' training courses as possible. Yeah, thanks for watching.